So we look here in section 2.3, we discussed a vertical transformation of a function by adding or subtracting a number d to the x value. So for example, if I had this, y equaled the square root of x plus 4, I told you that this plus 4 was on the outside of the parent function. Outside affects the y values, so we're shifting the graph up 4 here. Right here, this minus 3 on the outside, that's going to shift the graph down 3. An easy way to think about a vertical shift is to draw a horizontal line according to the vertical shift and use this as your new axis. So right here it says, what is the vertical shift for the function? A part, y equals sine of x minus 6. So what shift are we looking at here? We're looking at a shift down 6, or a shift of negative 6. We're going to subtract 6 from the y's. And then B part, we're looking at a shift up 2 because of that plus 2 on the outside. So remember, on the outside, it does what it looks like it should do. A positive shifts it up. A negative shifts it down. But when we're inside, affecting the x's, it does the opposite of what it looks like. Okay, so they did one here for us. It's already been graphed. They took y equals sine of x and added 1 to it. So what were my critical points for sine of x? Those critical points would be 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi, 0. And remember, we can find these by either memorizing them or by rotating around the unit circle. Okay. Here, we're adding 1. So I need to add 1 to all of these y values. So instead of 0, 0, I'm at 0, 1. Instead of pi over 2, 1, I'm at pi over 2, 2. Pi 0 becomes pi 1. 3 pi over 2, negative 1 becomes 3 pi over 2, 0. And 2 pi 0 becomes 2 pi 1. And this is what it looks like graphically if I shift the graph up 1. What they were explaining there about the vertical shift of a line. So when I look at the original sine function, I think about it as going above and below this horizontal line. And what we're doing is we're shifting this line up 1. Right, so I'm still doing the same pattern, but I'm moving the entire graph up 1. That's kind of what you can think about visually. And this here is what you would do algebraically to find the new points. Questions about that? So now we want to graph and state the 5 key points for cosine of x minus 4. So I see this one is a cosine graph. So when I list my critical points for cosine, that one starts at 0, 1. So we start on a high point, and then we're going to go to pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and 2 pi, 1. So I don't really care if you graph these parent functions or not. Some people like to graph them, some don't. But if I were going to graph it, it would be here, 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 here. I did a bad job. Okay, something like that. It's what my parent function should look like. Now, if I'm shifting all of this down 4, right, because that is the transformation that's being done, then what I want to do is subtract 4 from all of my y values. So this becomes the point 0, negative 3. The next one is the point pi over 2, negative 4. pi negative 5. 3 pi over 2 negative 4. And 2 pi negative 3. And so if we were to graph those on the same graph, I go, right here was negative 1, negative 2, negative 3, negative 4. I need another point, negative 5. Okay, so I'm at 0, negative 3. So it'd be here, going down, coming up, going up, going down, coming down, coming up, coming up. And so that's what my new function would look like. All right, I've shifted it down 4 from the red to the blue. Any questions about a vertical shift? How that works? Okay, so now we're going to work one that has a vertical shift and a little bit more. All right, so I'm going to give you a minute. Think about what we need to do here, and then we're going to graph it. Okay, so first thing we need to identify, what is my parent function?
Excuse me, teachers. Today we're doing access testing again over in Miss Amy Thompson's room. The bells will be turned off, and just remember, students, be very quiet if you're over there in the second grade hallway around Miss Amy Thompson's room. Thank you.
Does everybody know what the parent function is? It's cosine. Because it says cosine. So I need to then identify what are the critical points for my parent function, cosine.
0, 1. Power to 2. Pi negative 1. 3 pi over 2, 0. 2 pi 1.
Okay? So that's my starting points. That's where this graph originally is at. But now this specific graph has got a couple of transformations done to it. What are those transformations?
Plus pi 4.
So the plus pi over 4. So what kind of transformation is that called? That's one we looked at Friday. It is a horizontal shift, but it's got a specific name in trig.
Phase.
It's called a phase shift. Okay? So I abbreviate that. Phase shift. And what is that phase shift? What am I going to be doing? Left, pi over 4. Because it's on the inside, it does the opposite of what it looks like. So a positive in my head thinks to the right, but it actually shifts the graph left, pi over 4. Okay, so that's the first transformation. What's the other transformation?
Vertical shift plus 3.
Very good. I have a vertical shift, and I'm going up 3. Right, plus 3 is going to move the graph up 3. So you can do this however you want to, For me, because they're both being added, one is to the x, or I say added, they're both being added and subtracted, right? We're subtracting from the x and we are adding to the y. So you could do this as two different transformations, or you could do it all as one to save you a little bit of writing. So if I look at the original point 0, 1, what happens if I go left pi over 4? I'm now at negative pi over 4. And then if I go up 3, that means I'm now at 4. Is everybody okay with that reasoning? Okay, for the next point. It was at pi over 2. But if I need to go left pi over 4, that means I was at a half, but I'm backing up a fourth. Where am I at? It's at pi over 4. And then up 3 is going to put me at 3. The next one, was it pi? Now if I back up pi over 4, that leaves me at 3/4 pi, 3 pi over 4. And then up 3 is going to put me at 2. 3 pi over 2. And I back up pi over 4. So that would be 6 pi over 4 minus pi over 4, which is at 5 pi over 4. I know my handwriting's not great on this. But that's 5 pi over 4. And if I go up 3, that puts me at 3. And then 2 pi minus pi over 4. That's 7 pi over 4. Up 3 puts me at 4. Okay, so now I need to graph it. So these tick marks still represent, this is pi over 2, pi, 3 pi over 2, and 2 pi. But now all of my points are at pi over 4s. So where was pi over 4 at? It would be halfway between 0 and pi over 2. So the tick marks that I'm going to be using are going to be these in-betweens, these halfways. So you can either draw them in. That's what I would do. And so I know the reds represent a pi over 4. And the blacks represent a pi over 2. So now when I graph this, my first point is at negative pi over 4, and I have to go up to a y value of 4. So I'm here at 1, 2, 3, 4. Okay? Then I have a point at negative pi over 4, 4. Should be here. I'll line up with the red. And then pi over 4, I'm at 3. At 3 pi over 4, I'm down at 2. 5 pi over 4, I'm back up to 3. 7 pi over 4, I'm up to 4. And I want to fill this pattern out for the rest of the red tick marks. So here I would be at 3, here I'm down to 2. And here I'm back up to 3. So that graph would look something like this. So right now I'm looking at 2 transformations. I'm looking at a phase shift and a vertical shift. Did I go too fast? This transformation is the one that seems to mess up more people than any of them. Okay, so you need to make sure you're paying attention and ready to go. So the period P of a function is given by the formula P equals 2 pi divided by B. And so what this B is a number that's being multiplied inside of my function. So what you have to know with these periods is we've already established that sine and cosine have a period of 2 pi. It defaults to 2 pi. If nothing's happened, the period is 2 pi. But now when I look at these, you can see how I'm multiplying by something inside. So now I am changing the period. So let's go through how to identify what the new period would be. So for the first one, I've got the function y equals sine of 4x. So here's the way I think of it in my head. What used to be the period of sine? It's 2 pi. And now, what is happening here as a transformation?
Like you mean like?
I'm not saying on the graph what happens, but like on the phase shift, when we had plus pi over 3, that meant I was going left pi over 3. On a vertical shift, if I had a plus 7, on the outside, that meant I was going up 7. Right here, what does it look like is happening?
Left, horizontal.
Okay? My x is being multiplied. Does everybody see that? It's being multiplied. Is that inside or outside?
Inside.
Inside. So on the inside, it does what?
It does the opposite of what you think.
It does the opposite of what it looks like it should do. So right here, x is being multiplied by 4. So what's that going to do to my period? Divide by 4. The inside always is the opposite of what it looks like it should do. So because I'm multiplying by 4 on the inside, that means I'm going to divide all of my x's by 4. Inside affects x's. Outside affects y's. So if I simplify this, this means that my new period is going to be pi over 2. So what does that mean if I have a period change? Well, my original graph, and this is just a rough sketch here. 1, 2. So for sine, it normally took two pi radians to complete one full cycle. And that's 2 pi. This is pi over 2, pi, 3 pi over 2, 2 pi. now if my period is now pi over 2, what's happening? The graph is doing a full sequence 4 times as quickly. Because my period is being changed by 4, and now a period is going to complete a cycle in pi over 2. So this graph is going to reach its high point. It's going to be back down here. It's going to reach its low point. And it's going to be back here in pi over 2. It's done one full cycle in a shorter time frame. Pi over 2. So in that same 2 pi, I'm going to reach the high point, back down, low point, here. High point, back down, low point, here. High point, back down, low point. Again, rough sketch. But that's what's happening. My graph is being changed with a period change. This is what it looks like. B part. It's a cosine. What's the normal period for cosine? How long does it take cosine to repeat itself? 2 pi. So I always have to put the 2 pi up top, because that's the default period. And now, what's happening to the x here? X is being multiplied by pi over 2 on the inside. So to find my new period, I have to divide by pi over 2. So now if you have a calculator, you can probably plug this in and find the number. I don't have one. So I have to do 2 pi over 1 and then multiply by the reciprocal. So now what's happening here? My pi's cancel. 2 times 2 is 4. So now the period of this function would be 4. Which means, you know how we've been cute with our x values and treating them as pi over 2, pi, 3 pi over 2, and 2 pi? Well, if I had to graph this function, I don't want to be cute. I want to do like I'm used to doing. I want to number 1, 2, 3, 4. And then after 4, it's going to do a cycle. So whenever the number being multiplied has a pi in it, you know those pi's are going to cancel out. It's just like how, you know how sometimes we have radians. It's like 2.7 radians. I'm not dealing with a pretty radian, 3 pi over 2, 2 pi radians. Sometimes those pi's cancel out. And that's what happened there with B. Okay, C part. My original period is 2 pi. Now what's happening to x here? What's the transformation for C? Being divided by 3. How can I undo that? Multiply by 3. So my new period is 6 pi. So what's the graph of this look like? This time my period got greater to be 6 pi. So what does that mean?
It got big.
Not necessarily. It didn't get any bigger, right? Because like if I look at this graph, the highs are the same highs. The lows are the same lows.
Is it the space in between? Stretch?
It got stretched horizontally. The way I think about it is it's going to take longer to complete one full cycle. So if this is my normal 2 pi, and I get one full cycle done in 2 pi, now with this graph, it's going to take all the way to 6 pi before I complete a cycle. This would be 4 pi. 6 pi. So the red graph is what used to be one cycle, but now then the graph's going to grow much more. And I don't know if I'm getting all the points exactly right. Boy, that's awful. Okay? But it's taking longer to complete one full cycle. Okay, right here we've got some graph for us here. It says if a function y equals sine of 2x has a period of pi. So you could actually fit 2 cycles of the graph y equals 2 sine x in a normal period for sine of 2 pi. So right here is we graphed y equals sine of 3x. So you can see here the bold one is my original parent function. This is sine of x. If I were to graph sine of 3x, now then the graph is happening 3 times as quickly. So right here where I could only originally fit in 1 cycle of sine, I should now fit in 3 cycles. There's 1, 2, 3. Right? It's happening 3 times as quickly. So now let's talk about what does that look like with our key points, our key features. So this is what parent function? Sine or cosine? Sine. So I need to know my critical points for sine are 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi 0. Hopefully you're starting to get those memorized. Or at least a few of them. Because without those, we are useless.
Excuse me, teachers. The elementary library is open for the book fair now if you want to send your students. The library is open for the book fair. Thank you.
So, here's the way I think about it. If it asks me for the period, what's the original period of sine? 2 pi. But now here, we are affecting the period by multiplying by 3 on the inside. So what do I have to do? I have to divide everything by 3. So my new period is going to be 2 pi over 3. That means this last point, x value, should be 2 pi over 3. Because what are my key points here? They're showing me how long does it take to do 1 cycle. Well, I know my cycle is going to end at 2 pi over 3. So again, what did I do to find this new period? I had to divide by 3, the original. So what am I going to do to all of my x's? Divide by 3. What you guys are going to do is you're going to start dividing by 2 pi over 3 because that's the new period. Or you're going to try to multiply by 2 pi over 3. Or add or subtract. It's going to happen. You're wrong. This is the way I want you to think about it. What did I have to do to find this period? I had to divide by 3. So I need to divide all of my x's by 3, and this last x value is going to match my period. They match. Okay, I told you. All right, so now, what did we do? We divided all the x values by 3. So let's do it. Divide every x value by 3. 0 divided by 3 is still 0. Pi over 2 divided by 3 is pi over 6. Pi divided by 3 is pi over 3. 3 pi over 2 divided by 3 is pi over 2. 2 pi divided by 3 is 2 pi over 3. Any questions here? Now, just like when we did transformations before, the order that you do them in matters. Okay, so far out of the transformations we've looked at amplitude, then we looked at phase shifts, then we looked at vertical shifts. Now we're looking at a period change. Just like our normal order of operations, where you have to multiply and divide before we can add and subtract. In the transformations, you want to do everything that's being multiplied or divided first. Then you want to do anything that's being added or subtracted last. So that means the last things you're going to look for are going to be phase shifts and vertical shifts. It doesn't really matter which order you do those in. They just have to be done last. Okay? Then, above that, we're looking for period change. We're looking for amplitude change. And we're looking for any reflections. These can be done in any order. But you have to do those before you do period shift and phase and vertical shift. Not period shift. Phase shift and vertical shift. They're done last. The reds have to be done before that. Questions here? Okay, now we're going to graph and state these 5 key points for cosine. So what's my parent function? Cosine. So I need to identify my critical points for cosine. Those are 0, 1. Pi over 2, 0. Pi negative 1. 3 pi over 2, 0. 2 pi 1. Absolutely. 5 critical points. Boy, Hall. Now, what transformation has occurred here from my original parent function? I'm on the inside. Inside affects the x values. My x is being divided by 2, which means it's a period change. So if I was dividing x by 2, then to be able to fix that, I need to multiply all of my x's by 2, because it does the opposite of what's happening. So let's multiply all the x's by 2. So it's going to put me at 0, 1. Pi 0. 2 pi negative 1. 3 pi 0. 4 pi 1. Now you know when we did phase shifts and we shifted the graph left or right, and I kept saying these tick marks are still evenly spaced. So I can't make the first one pi over 4 and then the next one 3 pi over 4. Because that's not equally spaced. That gives me pi over 4 distance here and then pi over 2 distance here. Doesn't work. When I change the period, I can change my x's. Because all of these are evenly spaced. From 0 to pi, from pi to 2 pi, 2 pi to 3 pi, 3 pi to 4 pi. So when I have a period change, I'm going to change my tick mark values every time. My first tick mark value is pi, 2 pi, 3 pi, and 4 pi. And now when I graph these, because I'm cosine, I'm at 0, 1, pi 0, 2 pi negative 1, 3 pi 0, 4 pi 1, and then continue the pattern. So on the graph, this actually looks just like my original parent function, cosine. But why is it not the same? Because the values of the tick mark are different. That's how I've changed the graph. I've changed that window. I've changed what I'm looking at. If you were to graph the original in this window, it would look like this. Right? I would get, oh sorry, I'm an idiot. I graphed sine. I was thinking, God, what a great job I just did. There we go. That looks better. So if I graph the original cosine in this same window, this is what it would look like. Where I could get 2 full cycles done in the time it takes the red one to do 1 cycle. Right? I've just changed the window. I've changed those x values. I mean, all that other stuff that we just looked at, that's like algebra 1, fringe algebra 2 level. Like, that's stuff that you're supposed to have learned before.
Just review.
This is the Precal level. This is what we're at now. Right? So I have to build it from algebra 1, algebra 2, but then I have to apply it at this level. So anyways, we're not graphing these, we're just identifying. Look what the question is. What's the amplitude? What's the period? What's the phase shift? What's the vertical shift? So those 4 things that can change, we're going to identify each one of them. Let's start with our generic. Let's start with one that's not even up here. What if I ask you for just sine of x? Okay, what is the amplitude for sine of x? So what did amplitude represent?
The height.
It's the height, how high and how low it got. And remember, we had a formula for amplitude. It's the highest y value minus your lowest y value divided by 2. So for sine, what's my highest y value? 1. What's my lowest y value? -1. So this would be 2 over 2, which is 1. So the amplitude of sine of x defaults to be 1. If there is no amplitude change, the amplitude is 1. The amplitude is not none. If the amplitude was none, you would have a graph that didn't exist. It has to have a high and a low. The amplitude is never none. The amplitude is never none.
So like never.
Never. Why am I saying this?
Because we're gonna.
Because I see it every year.
Does not exist.
The amplitude is never none.
It's never D.
Next, what is my normal period for sine?
2 pi.
2 pi. It takes it 2 pi radians to complete 1 full cycle. Next, what is my phase shift? So phase shift is shifting left and right. Did this graph get shifted left or right? No.
No.
So there is no phase shift.
No vertical.
Just because there is no period change, the period's never none. Just because there is no amplitude change, the amplitude is never none. Phase shifts, if I don't move, it's none. Vertical shift, if I don't move, it's none. But all the graphs have an amplitude and a period. How long does it take the cycle to complete itself? What's the highest high and the lowest low? Can never be none or the graph doesn't exist. These can be none. You don't have to shift the graph left or right. You don't have to shift the graph up or down.
That was just the easy one.
Let's do A.
Let's do A.
Let's do it.
Woo. So let's start with amplitude. So where does the amplitude show up in the graph or in the equation?
It's a great question.
Amplitude affects what?
The height.
heights and the lows. So that's the y values. Where does everything that affects the y values happen?
Outside.
Outside.
So it's -4.
So the outsides are 3 and -4. One of those is amplitude, one of those is vertical shift. Which is which?
3 is the amplitude.
3 is an amplitude change because it's being multiplied. It's a stretch or compression. -4 would be my vertical shift. That's shifting up or down. It's being added or subtracted. So in this problem, my amplitude would be 3. And since we've already talked about it, the vertical shift would be -4.
I thought this was supposed to be hard.
Okay, well, we're not graphing it yet. I haven't done anything with the critical points. Now, the period. What's my original period for sine? 2 pi. And how does the period change? If something on the inside is being added or subtracted. I'm sorry. If something on the inside is being multiplied or divided, that changes the period. So here, I have x being multiplied by 2. So my new period, I have to divide the original by 2. Because it does the opposite of what it looks like. So multiplied by 2 on the inside means I'm going to divide by 2. The original period for sine is 2 pi. 2 pi divided by 2 is pi. Period is pi.
So which one did we divide by 2? And then,
We divided the original period, which is 2 pi. You have to know the original period is 2 pi. So I took 2 pi and divided by 2.
so like your first x is your period. That's gonna be the one you.
The thing that's being multiplied or divided.
So whichever one looks like it's kind of like distributed into.
That's multiplied. Yes. Yes. Okay, then do I have a phase shift here? Something on the inside being added or subtracted? Yes. Which direction?
It would be right.
Right. Pi over 2. Because it's the opposite of what it looks like it should do. So my phase, exactly, right. So my phase shift is right. Pi over 2.
See.
Can, questions on A? Now that we've done it, we should be able to do B a little bit more quickly.
Let's do B by ourselves.
I know, because I got to do one of these before we leave. So let's do B quickly. B, what's the amplitude?
A is 2.
2. What is my period?
It is. Let's see. Cosine. What's the thing for cosine?
It's 2 pi. The original period for cosine is 2 pi.
So you divide by 3.
So I divide by 3.
So you get 2 pi over 3.
Yes.
For your period.
Yes.
And then you go phase shift.
The period is 2 pi over 3. Phase shift.
Would it be pi over 3 left?
But it's going to go left, pi over 3. So I would call my phase shift negative pi over 3.
Okay.
And my vertical shift,
Positive 1.
up 1. Going up 1. Okay, so real quickly, what's the only thing different on C? Or how about this? What's the amplitude of C?
It's just -1.
Wrong.
Guys.
Amplitude is always positive.
So it's 1. It's 1.
It's 1. The amplitude is 1. What's this negative going to do?
Nothing.
It's going to be a reflection over the x-axis. Right?
It's basically the same thing. It's basically the same thing.
Let's go.
And now D part, what looks different from D than these 3?
It's
does
pi
it-
in the.
Well, this one has pi in it, but the thing that was being multiplied is now only being multiplied by the x. So what you have to do is factor. You're going to have to get x by itself inside. So right here I could factor out a 2. So I can rewrite this to be negative 3 times cosine of 2 times x minus 2 pi.
What if you don't do that?
So before you can identify these, you have to make sure the x doesn't have anything being multiplied or divided directly in front of it.
That'd make
Okay.
it more complicated.
Because what happens is people mess up the phase shift. Because right here it looks like the phase shift would be right 4 pi, but it's not. It's only right 2 pi after a period change. All right, y'all are